The purpose of this video is to give you some help with your 2.7 homework assignment. I'm going to do one of each problem out of each section, and hopefully that will be enough help so that you'll be able to do the rest on your own. So let's take a look at number 1. The directions say, write the system of linear equations represented by each matrix equation. So in each of these numbers 1, 2, and 3, we have a coefficient matrix, a constant matrix, and then a coefficient matrix, a variable matrix, and then this is the constant matrix. So let's go ahead and rewrite this as a system of linear equations. So 2 and 3 are the coefficients of your first equation. So the first equation would look like this. 2x plus 3y equals this constant of 10. And then our second linear equation, this is your x coefficient, this is your y coefficient, so it would look like this. 6x plus 4y is equal to 8. All right, so we've written a system of linear equations, so you're done at that point, and that's all you need to do. Do the same thing for numbers 2 and 3. All right, let's take a look at number 4. Number 4, the directions say, write the matrix equation AX equals B for each system of linear equations. All right, so remember, A is the name of a matrix, X is the name of a matrix, and B is the name of a matrix. A is your coefficient matrix. It's going to be a 2 by 2 because you have 2 rows and 2 columns. X will be your variable matrix. It'll be a 2 by 1. We only have 2 variables, X and Y. And then B will be your constant matrix. It'll be a 2 by 1 matrix because we just have these two constant values. All right, so let's start with our coefficient matrix. It's going to be a 2 by 2. Remember, when you write a matrix, it's a rectangular array of numbers that is surrounded by these bracket symbols. So matrix A is your coefficient matrix. Our coefficients of the first row would be -2 and 4. So just write -2 and then 4. And then in the second row, these coefficients, they're invisible, but they're both there. They each have a coefficient of 1, so we'd write 1 and 1. So that's our A matrix, our coefficient matrix. Now, we're going to write our variable matrix, and it's a 2 by 1, so it's kind of skinny. Our variable matrix, we just need the X and the Y in that matrix. And then we're going to set that equal to matrix B, which is your constant matrix. It's another 2 by 1. So we'll just put the 2 constants in there, 3 and 5. All right, so this is, that's matrix B. This is what we call a matrix equation. The direction said write a matrix equation, so you're done with that at that point. So do the same thing on numbers 5 and 6. All right, then number 7, the directions say rewrite each matrix equation in the form X equals A inverse times B. This A inverse times B is the arithmetic that we're going to have the calculator do to find our solutions to these systems of equations. So look at 7. This is already a matrix equation. This is your coefficient matrix A. This is your variable matrix X, and this is our constant matrix B. We want to make it look like this. X equals A inverse B. So we'll put our variable matrix first. It's a 2 by 1 that has an X in the first row and Y in the second row. And then that's our X matrix. And then we're going to set that equal to A inverse. So go ahead and make this bigger. You need 2 rows and 2 columns. And remember, we're going to take the inverse of A. And the way we indicate that is with this little -1 exponent. So when you raise something to the negative first power, that's the way we indicate the multiplicative inverse of a number or an expression, or in this case, a matrix. So remember, capital A is your coefficient matrix. Our coefficients are 2, 3, 6, and 4. So put those in that matrix, 2, 3, 6, and 4. And then we're going to multiply that A inverse. This is A inverse. We're going to multiply A inverse times B, which is our constant matrix. And our constants in this problem are 10 and 8. All right, so the direction said rewrite it in the form X equals A inverse B, and that's exactly what we have. Our variable matrix is equal to the inverse of the coefficient matrix times the constant matrix. So that's all we have to do with number 7, and then do the same thing with numbers 8 and 9. All right, and then the bottom of the front, this is an Algebra 1 level word problem, okay? There's enough information given in the problem so that you can write 2 equations and 2 unknowns. So all you're going to do is just follow this step by step. It's just like you've done before, writing a system of linear equations to solve a word problem. The only thing that's new is that you will step by step rewrite it as a matrix equation and then rewrite it in this form. Use the calculator to find the solution, and then write your solution in a complete sentence. All right. I'm going to show you how to do this work on the calculator, so you might want to flip over and do the back side of the worksheet, and then you could come back and do numbers 13 and 14. All right, I'm going to show you how to do number 18 on the back of 2.7 homework. Just taking a look at the directions, it says use matrices to find the solutions, if possible, for the following systems of linear equations. So I'm just going to give you a heads up. A couple of these, when you try to do the calculator work, when you try to take A inverse times B, you're going to get an error message. Okay, what that means is, remember we're talking about a system of 2 lines in a plane. If you get an error message, that means you're either looking at 2 lines that are parallel or 2 lines that are coinciding that are actually the same line. So if in this step you get an error message, go back, take a look at your linear equations, analyze their slopes and y-intercepts like we have before, and then from that information you can write over here in the solution area, write either there's no solution or there's infinitely many solutions depending on what you found out when you analyze their slopes and y-intercepts. All right, well, that's not going to happen with number 18, so let's take a look at number 18. Okay, first of all, we need to write the equation in standard form, both equations in standard form if they're not already in that. So just a reminder what standard form is. It is ax plus by equals c. So we need an x term and a y term on the left side in that order, and then a constant term on the right. So looking at number 18, this first equation is not in standard form. This negative 2x term needs to be over on the same side with the y. So I'm going to move it over here. The algebra that I'm going to perform, and I'm just going to do this mentally, I'm going to add 2x to both sides. So if I were to add 2x to both sides, 2x would become positive on the left, okay? We already have the positive y on the left side of the equal sign, and then that's going to be equal to this positive 3. All right, that gets our first equation in standard form, and if you take a look at the second equation, it already is in standard form. It has an x term and then a y term on the left, and your constant term on the right side of the equal sign. So let's rewrite that. Negative 2x plus 5y is equal to negative 9. Now, as I take a look at this system, this would be a great time to use elimination. However, we're practicing using matrices, so let's go ahead and do that. All right, so now what we're going to do in this area is we're going to write this matrix equation. We're first going to put our variable matrix. Remember, capital X was the name of the variable matrix. In this case, we'd have X and Y. It'll be a 2 by 1 matrix. All right, and then that's going to be equal to, we're going to now write the inverse, or not write the inverse, but we're going to write matrix A, which is our coefficient matrix, okay, and indicate the inverse by raising it to the negative first power. So our coefficient matrix, top row, our coefficients are 2 and 1. So write a 2 and a 1 in the first row, and then the bottom row would be negative 2 and positive 5. Negative 2, positive 5. And then we're going to multiply that by capital B, which is the name of your constant matrix. That's equal to, or that is, contains our constants, which are 3 and negative 9. That's going to be another 2 by 1 matrix. All right, so that's the setup. Now, in just a minute, I'm going to show you the steps of how to do this arithmetic on the calculator, but let's go ahead and just set up our last column to get our solution matrix. Our solution matrix will give you the value for x and the value for y that make both of these equations true at the same time. All right, so let's review how the steps that we do on the calculator to do this arithmetic. Just a reminder, in your note packet, those steps are typed out step by step. So if you want to get that note packet out and follow along, or if you ever forget a step, you can go back and look at that. But as I told you in class, after you've done this 2 or 3 times, you really won't need those notes anymore. That's just in case you needed to go back and refer to them. All right, so let me pull up a calculator, and we're going to review how to do this arithmetic on the calculator. So first of all, we need to turn the calculator on. Oh, please turn on. Okay, there we go. And I'm going to just clear out the work I've done before. I want to start with a fresh calculator. All right, so I'm going to take, remember to get our solution, we're going to be taking the inverse of the coefficient matrix and multiplying it by the constant matrix. All right, so the first thing I need to do is to create a matrix A. So the keystrokes you'll do on your calculator, do you see right above here this x to the -1 key? See the matrix on my calculator it's in blue, it might be in a different color on yours. So to get that matrix menu, I need to hit second and then x to the -1 key, and I have this menu. Now I'm going to create or edit a matrix A, so use your arrow key to arrow over to the edit part of the menu. So look what's highlighted, edit matrix A. That's exactly what I want, so I want to hit enter. Now the first thing the calculator will ask you is the dimensions of matrix A. Well, matrix A has 2 rows and 2 columns, so it needs to be a 2 by 2 matrix. So just hit 2, enter, and then hit 2 again and enter. And, oops, what did I do here? Let me go back. Oh, sorry. Let me start over. Second matrix. Oh, how do I get back up here? All right, let me clear. Oh, I can't. Let me quit and get out of this and just start over. I'm so sorry for this little blip. Okay, let me do that again. So we're going to edit matrix A. Look, here's how I had it typed in there wrong. So we're about to fix that. I'm going to hit enter, and we're going to make this a 2, enter, and then hit 2 again, enter. There we go. Now we have a 2 by 2 matrix. All right, so now the calculator wants you to type in your elements of the matrix. I'm going to put 2 and 1 on the top row, so just hit 2, enter, 1, enter. And then on the bottom row, I need -2 and 5. When you type in a negative number, be careful, don't use the subtraction sign, use this negative sign down here. So I'm going to type in -2, enter, and then 5. All right, just a quick check because you got to make sure you have the right numbers typed in. I need 2 and 1 on the top row, -2 and 5 on the bottom row. All right, so now after you have set up a matrix, we want to get out of this screen, and the way we do that, see this quit function right here? Just hit second mode, and that will quit and get you out of the screen. So now I need a matrix B. All right, so I'm going to go back to that second matrix key. Here's my matrix menu. I want to edit, but this time I don't want to edit matrix A. I need to edit a matrix B. So use the arrow key to edit down. So now we're going to edit matrix B, hit enter. The calculator will ask you for dimensions for matrix B. Well, matrix B has 2 rows and 1 column, so it's a 2 by 1. So 2, enter, and then 1, enter. Okay, and let's type in the elements for matrix B, 3 and -9. So 3, enter, and then once again use this negative key. Don't use the subtraction key or the calculator will not like that. Enter. Okay, now after every time you're done putting elements into a matrix, the way to get out of that screen is second quit. All right, so we have our matrix A, it exists. We have our matrix B, it exists. So now we're going to let the calculator do this A inverse times B matrix multiplication for us. So I'm going to hit second matrix, and I want matrix A. So I'm going to hit enter. Okay, now we see the name of the matrix, Remember, these 4 elements are stored in the calculator's memory. Okay, all it's going to pull up though right now is the name of the matrix. If you want to see what's in matrix A, just hit the enter button and it would put your 2 by 2 matrix right here. All right, now I don't want A though, I want the inverse of A, and we're going to let the calculator do that arithmetic. Finding the inverse of a matrix is a little bit complicated by hand, so we're glad that the calculator can do that for us. So if I want A to the negative first, see this key right here, X to the negative first, hit that, and then you have exactly what you want. Now we're going to take A inverse B, A inverse, and multiply it by matrix B. So now hit second matrix. I'm going to arrow down to B this time. I want matrix B, so I'll hit enter. Okay, and now the calculator is waiting for you to hit enter. It's just like I had typed in 2 times 3, and when I hit enter, I'm going to get the product of 2 and 3. This time though, I have the inverse of a matrix times another matrix. The calculator is going to do that matrix multiplication, and it would be a little bit complicated to do by hand. So I just hit enter, and the result is this 2 by 1 matrix, which is our solution matrix. 2 is our value for x, and negative 1 is our value for y. All right, so I'm going to write 2, negative 1 in here, and we're done with number 18. So now go ahead and try the rest of these on your own, and if you have any questions, be sure and ask me when you see me again in class.